Okay, here I'm going to talk about the case 1 in which when you plot the graph, these kind of lines will be coming over here and lines will be intersecting line. Okay, this is the question I have taken and I need to decide in this kind of case is going to exist or not. So first I will apply any of the method, either substitution method or elimination method, and I'm going to apply over here the addition elimination method. Simply when I will add these equations, this y will cancel out because this y is plus sign and this y is negative sign will cancel out, and 2x equals to 4. And when now you need to divide by 2, when you divide, this is going to be x equals to 2. So we got the value of x2. Now this x value I need to plug in either of the equation. I have taken equation 1. Okay, and 2 plus y minus 2 equals to 1 minus 2, and so y equals to negative 1. I got the solutions at 2 comma negative 1. Okay, if you are getting the such kind of solution over here and you are able to solve the equations, this is the case of unique solution, and in this, because this solution is satisfying your equation 1 as well as equation 2, so this solution is going to be unique and consistent. Okay, now the thing is only we have not plotted over here graph. We have solved analytically and we have come to this conclusion that when you will plot the graph for these equations, you will be getting this kind of graph. Okay, so if you like, I'll be plotting the graph for you so it will make you more clear, and we see the graph. Okay, I'm going to plot the graph for these two equations. So to plot the graph, I need to write again, and I'm going to plot the graph for you. And the equation, now the equations I'm going to write again. X plus y is equals to 1 and x minus y equals to 3. This is equation 1, this is equation 2. Okay, now what I need to do to plot the graph, I need to take one by one both the equations. I am going to take first equation 1. I'll make table, and from this table I will, from my side I plug in two values for x and will get the y value calculated. Okay, so I am going to take any two value, but I prefer to take 0 and 1. Okay, so when you plug in over here 0 in this equation, 0 plus y equals to 1, so y value is going to be 1. Okay, now when you plug in x place 1, so I'm going to plug in x plus y equals to 1, and x place 1 when you plug in over here. Now I need to solve this to get the value of y. I'm going to solve, so this is cancel out, y equals to 0. Okay, so what the coordinate I am getting, 0 comma 1, and over here 1 comma 0. Okay, now similar way I need to solve it out for second equation. So I'm going to write over here x minus y equals to 3. Okay, for this equation also I am going to choose 2 points which are going to be 0 and 1. You can choose any point, it doesn't matter, but I prefer 0 and 1 always. Okay, and now I'm going to plug in over here 0. When you plug in over here 0, 0 minus y equals to 3, so negative y equals to 3, and this is negative. To remove this negative sign I need to divide, so when you divide, y equals to going to be negative 3, so this is negative 3. Okay, now I need to plug in x place 1, so I'm going to plug in 1 minus y equals to 3, so 1 minus 5 minus 1, 3 minus 1, so this 1 is cancel out. Now negative y equals to 2. To remove this negative sign I need to divide both sides, so I have divided by negative 1, so y equals to is coming negative 2, so I got negative 2. So first coordinate is coming 0 comma negative 3, and this is coming 1 comma negative 2. Now I need to plot the graph for both equations, this equation and the equation 2. Okay, so roughly I am going to draw the graph over here for you, and Okay, what are the coordinate I needed over here? Positive till 1, and over here till negative 3, and so this is 1, this is 2, this is 3, this is negative 1, negative 2, negative 3, positive side 1, 2 and 3, and negative side negative 1, negative 2 and negative 3. Okay, now I'm going to plot one by one coordinate. First coordinate I need to plot for L1 line. This I have considered L1 line. Now I need to plot these points for the L1 line, 0, 1. Okay, so 0, 1, 0, x 0 and y 1. So this is going to be the point. Okay, this is the point 0, 1. Okay, now second point 1, 0. So this is 1 and 0. Okay, so this is the point, and by matching these 2 points you need to draw a line. This is the line plotted for which equation? X plus y equals to 1. Okay, this is the line I have plotted. Okay, now the second I need to plot for the L2 line, that I am going to make for with red pen, and the coordinates are 0, negative 3. This is 3, negative 3 and 1, negative 2. So to mark this 0, negative 3, this is 0 and negative 3 is this. So this is point, and second point is 1, negative 2. So 1 is means x value is 1 and negative 2, so it is going to be here somewhere. Okay, so by joining these points you need to plot a line. This is the line I have plotted. Okay, so this green line and the red line, this is L2 line for x minus y equals to 3 for 3. Okay, and this is for x plus y equals to 1. Okay, you can see both the lines are intersecting. So this point is going to be your solution set. It is not exactly coming correct. Why? Because I have not plotted on the graph. When you plot exactly with the help of graph, it will be giving you the correct solution, because the correct solution what I got over here in the last, what was the solution? 2, negative 1. So okay, it's correct, absolutely correct, it's coming correct. Anyway, I have roughly plotted over here. This is when you draw a line from x to read the coordinate over here, and parallel to y, this point is coming 2, negative 1. So this is the value of x and y, or you can say the solution you got for these two equations. So this is the case you have seen when the lines are intersecting, and line intersect at one common point. This is called unique solution, and solution is consistent. Okay, so this one question I have taken and I have discussed with the case 1. Either you solve graphically or either you solve analytically. If you are solving analytically, and if the solution x and y value, x and y value is coming, you can say it is going to be consistent and unique solution. Unique solution means this kind of graph you are going to see, which I have plotted for you right now over here. Okay, unique solution. For unique solution, this kind of graph pattern will be coming up. Now in the next video I'll discuss for the second case, that is for parallel line. Thank you.